All right, so again, as we can see, here is our table of contents. We are starting Unit 8, the last unit of the school year, all about universe and galaxies and also some space mission stuff as we move along here. Again, page 1 is the Unit 8 table of contents. Pages 2 through 3 are into the universe day 1. Luckily, I think, this was a fill-in-the-blank activity with a really good movie called Into the Universe. But because at this time last year we were under we were like full e-learning, I did kind of make this to where it was more centered towards e-learners rather than the fill in the blank. So I think I have a solution for that today for us, and this movie will last us 2 or 3 days, so it should be able to get us through all that. We have for Go Blue, page 2. Go ahead. I need you to just illustrate number 1, the setup of a lunar eclipse. On page 2, number 2, then setup of a solar eclipse. And then for number 3 on page 2, I need the difference between neap and spring tides. Difference between neap and spring tides. Keep in mind the picture on the top. That is a solar eclipse, actually. We can see the moon blocking the sun. And the picture on the bottom is actually kind of a good view of a lunar eclipse. And just so you guys know, the next lunar eclipse, which oftentimes gives us kind of like a pink or a red moon, that's going to be May 26th. So if it's hopefully not too cloudy or raining that night, we'll be able to see a moon that looks like red or orange in color. Really cool, really cool. Updates, guys, we have a new vocab assignment that's just been posted to Canvas. That's not going to be due till next Friday, so get ahead on that, turn that in. Otherwise, make sure our online tests are completed and other missing assignments are turned in as well with that. And then we will have a notebook check arriving soon. We'll have another notebook check or 2, and we'll have. Sorry, guys. We'll have. Sorry about that. We'll have one more unit online test for the year as well. 2 parts, like we said before. Okay. Looks like, let me double check one thing again. Make sure if you haven't already, get a picture of that, write that down. Let me double check, see who joined us. Okay, got it. See Yorkies here. All right, just mark you here, Yorkies. Okay, let's go ahead and begin, guys. Numbers 1 and 2. If we look up here, got the setup of a lunar eclipse versus a solar eclipse. Well, for that, the answer for 1 and 2, guys, Go Blue number 1 and 2, we have the lunar and solar eclipse. As you can see in the picture, with the lunar eclipse, the moon is in the Earth's shadow. Okay, the moon is in the shadow of the Earth. Okay, these are much more common than the solar eclipses because the shadow is much larger. Okay, again, the Earth's in the middle, the sun, Earth, and moon. And we can see oftentimes when the moon is in the penumbra, that's when it's like a regular full moon, like that's white in color. When it gets behind that main shadow, the umbra, that's when it starts to begin looking like orange and red in color. And then secondly, we have the solar eclipse. Now instead, we have the moon blocking the sun from the Earth instead, switching places with the Earth. So that's where we get the more famous and less common solar eclipses happening there. Again, much less common because the moon's shadow is much smaller than the Earth's shadow, so it occurs less frequently, right? And again, if you're in Florida, last time we experienced the umbra, but if you're in that full darkness of the umbra, imagine it's like pure daylight, and then all of a sudden in a 5-minute time span, it's pure darkness and pure nighttime, which we didn't get to experience here in Florida, but was still really cool, Okay. And then lastly, number 3, spring tides and neap tides. Again, we've already got this, so take a picture, guys. Spring tides, again, are in a linear fashion. They're in a linear setup. And neap tides are at a right angle. So spring tides are going to be where the Earth and the moon work together. The sun and the moon work together to pull the tides to extremes, high tides, low tides. And the spring tides, here's our main idea, guys. Make sure to take a picture of that. With the spring tide, or the neap tide, the sun and the moon work at a right angle. That's where they're pulling the water so that it's a little more moderate, right? You don't get those super high tides or those super low tides. You get more of everything in between, the happy medium, right? So make sure you've got that, okay? For the Go Blue, And we're going to go ahead and move on to our first question of the day. So be ready to answer this question in the chat. Again, ready to answer the question chat. Anyone need more time on the Go Blue answers? Okay. Let's take a look at this then. We'll get into the universe notes on page 3 in a little while. That'll be in a little while. Let's go ahead and take a look at our practice question number 1. Number 1, here we see a picture. It's a half moon. It's shaded on the right and light on the left. Is this an A, first quarter moon, B, third quarter moon, C, waning gibbous, or D, waxing gibbous? What is the right answer? Again, for participation credit, please answer in the chat. Okay, thank you, Isaac. I'll give you guys 30 seconds. Please answer in the chat. Again, if you do not answer in the chat, you will not get the participation. That affects your quarter grade. Thank you, Lakia. Thank you, Joseph. Thank you, Irina. Great job, everybody. Okay, take about 10 more seconds. 10 more seconds to answer. Thank you, Yorkies. Daniela, great. Thank you. Okay, 5, 4, 3, 2, 1. Final answers. The answer, guys, is letter B, the third quarter moon. You might remember that on the moon test, we had matching sections for this, right? Third quarter moon. If it were opposite, where it's lit up on the right and half full, that would be the first quarter moon. I want to give shout outs and props to Yorkies, Daniela, Irina, Joseph, and Isaac for getting the right answer. Great job, everybody. Great job. Fantastic. Moving on now to our first topic of the day. We've got to talk about Redshift and Blueshift. What is that? What does that even mean? Oh, thank you for the answer, Lakia. That means, guys, again, we're looking at the different colors of stars, right? So write the first question on page 2. What is the difference? And actually, you guys can write this on page 3 if you'd like. You can write this on, so I'm going to say for our class, we're going to write this on page 3. Let's do that. That way, if I have a notebook check for this particular page, it's on the right page. Because like I said, guys, I'm going to show us shorter videos, not just movie notes that go with the fill in the blanks. So what is the difference, number 1, between Redshift and Blueshift? And then 2, are most stars in Redshift or Blueshift, and why? So we're looking at the colors of stars. Right? Note, all stars are not the same color. In fact, our sun, our star, is going to be yellow in color. Okay, so why do stars appear to be different colors in space? And what does it mean when they're red or blue, right? So what and why? What and why? I'm going to leave this up for 10 more seconds. Feel free to take a picture. Again, we're going to keep this on page 3. Keep this on page 3. See what you guys got in a little bit. Okay. All right. Well, let's find out our answer through our first video today. So what is Redshift and Blueshift? And then how does it relate to our stars?
Grammarly does more than catch errors. As a matter of fact, for what it's worth.
All right, 1 second. All right, so we got our first video today. This, again, answers our first video questions. I'm going to get the sound system set up. 3, 2, 1, 3, 2, 1. Starting for our first question.
Hello everyone, and welcome to our universe. Today we'll be answering the question, what is Redshift? So this is going to be quite a quick video, basically explaining what Redshift really is. So astronomers often use the term redshift to describe how far away objects really are.
And again, if you look here, we can see a picture of space, right? We can see a lot of these are orange and red, some pinks, and then we also see some blues in the background as well. And why do we see these different colors in these galaxies and stars? Let's find out. My bad.
So basically explaining what redshift really is. So astronomers often use the term redshift to describe how far away objects really are. To understand what cosmic redshift is, we must think about sound. A great example of this is a police car. You hear its siren because the waves travel through the air into your ear. If the police car is moving, then the sounds in front of it are compressed and create a higher frequency sound. And the sound waves behind it are stretched out, creating a lower frequency sound. As the police car passes in front of you, you would hear the familiar Doppler shift. Light is quite similar. It also travels in waves, and it's quite a similar process to what is happening within the waves. Light waves are able to be compressed and stretched, just like sound. But with sound, you would change the frequency, but with light, you change the color. Blue light has shorter wavelengths than red. When an object in space moves towards us, the light waves are compressed into higher frequencies, and this is why the light is blue shifted. It's shifted towards the shorter wavelengths. But when an object moves away from us, the light waves are now stretched. These waves now go into the lower frequencies, and this is what's known when light goes to redshifted. It shifts to the longer wavelengths. So how do we calculate distance by using redshift? Well, the light from the most distant objects in our universe is redshifted, very redshifted, as seen from Earth. And this is basically because the universe is expanding. That the further away a galaxy is, the faster it is moving. And the faster a galaxy moves, the more its light is redshifted. So by measuring the amount of redshift is a great way to measure the distance of the galaxy relative to Earth. By using cosmic redshift, astronomers are able to measure the distance of galaxies as far as 12 billion light years away. With the latest technology that we have in space telescopes and ground-based telescopes, we are pushing this cosmic redshift limit even further back, looking into the deep parts of the universe and telling us really how the universe was created and how it evolved.
All right, so some really
So I hope that's given you a great
really
insight.
good information there, and to the point compared to our movie. Right, again, I am going to show some of the movie for you guys because there's some, and the movie's awesome. It's just it would be a lot with the fill in the blank sheet that I'm providing in class. So just breaking it down simply through the presentation is a much better way of doing it. Doing this for us online. So redshift and blue shift. Why do we get stars that look blue? Stars look red. What's the deal with that, and what are most going to be categorized as? Well, number one, guys, again, you're going to write this on page 3. On page 3, right? You got to know redshift is when objects move away from a source. So sound waves work this way, right? When a car approaches or goes away, the pitch increases and decreases, right? But also light works the same way. Don't forget, light is faster than sound. The speed of light's faster than speed of sound. Okay. So redshift objects move away, the waves get stretched, as you can see here in this image below. And in blue shift, it's just the opposite. Again, make sure to write this down on page 3, guys. Make sure to write this down on page 3. So blue shift is when objects are moving towards a source, right? Towards a source, and the waves get compressed. They get kind of pressed together, right? So again, object moving towards redshift, object moving away. Now, most stars, most galaxies we see in space are going to be red, yellow, and orange because, well, what do you know? The universe is expanding. Yes, the universe keeps growing, kind of like a bubble that's inflating as we speak. So most space objects are in redshift because of that. And over time, all the other parts of space, the other galaxies and solar systems, they're drifting further and further away. Okay, so make sure to have a picture of that if you like to go at your own pace. I'll leave this up for another 5-10 seconds, and we'll move on to our last topic of the day, which is going to be about the Big Bang Theory. Okay, very controversial topic, right? And just understand that science can't answer all of life's questions. Science has many, many flaws, and theories can change and can change over time, right? So anything within the scientific realm, it has to be like what we can physically see. So anything that has to do with like the human spirit, the human soul, and what happens after life, science has no answers for that because science can't look at a human soul. It can't see the human spirit, right? So this is science's way of trying to figure, okay, if we just took the physical aspects of life, physics, matter, atoms, energy, and we tried to figure out how it all started. What would be the story or the idea behind that? That's what the Big Bang Theory is, right? So let's take a look at for this next one on page 2 or page 3. Just put down, what is the Big Bang Theory? Again, what is the Big Bang Theory? We'll just put that down. Okay. All right. So go make sure you got that down on page 3, guys. What is the Big Bang Theory? And let's check out 2 videos, and then we'll call it a day. This will be it for the day. I'm gonna have kind of Stephen Hawking do one of his films explain it here for us.
In fact, the whole universe.
So let's take a look here. How the Big Bang worked. So before we get started, think of it like a ball of light. So in the beginning of space, there was nothing but darkness and nothing but pure darkness. And then we get a little ball of light that simply bursted. And it wasn't like an explosion, like a firework explosion or a supernova. It was more of like the light just kind of expanded and inflated into space, like an aurora or beams of light. Let's check out what that looks like.
Is expanding in all directions, getting bigger and bigger, like a balloon inflating. I admit this sounds strange, but to cosmologists, it's like winning the lottery. Because to work out where the universe came from, all we need to do is to stop time and make it run in reverse. Rewind far enough, and everything gets closer together. A lot closer together. All the galaxies, in fact, every single thing, converges to a single point, the start of everything, 13.7 billion years ago. So it's quite simple, really. Follow the clues, and we can deduce that a very long time ago, the universe simply burst into existence. An event called the Big Bang.
Again. Sorry about that, guys. It wasn't an explosion like this.
We have to stop a moment.
Let's see a more accurate view of it here in 1 second.
Noise. At the very beginning, the Big Bang actually happened in total darkness because light didn't exist yet. To see it, we'd have needed some kind of cosmic night vision. But even this, a view from the outside, is impossible. Again, it sounds strange, but space didn't exist then either. So there was no outside. The only place there was inside. This early universe was a very strange thing indeed. There's still much I'd dearly love to know about it, but standard concepts of time or space don't really apply. It was just a very tiny, ultra-hot fog of energy. Then it expanded. With a tremendous flash of radiation. From smaller than an atom to about the size of an orange in less than a trillionth of a second. Almost no time at all. The universe simply inflated into existence, unfolding, unfurling, getting bigger and cooler with every passing moment. Within 100 seconds, it was as big as our solar system, trillions of miles across. While this was happening, the pure energy of the cosmos began to cool and create matter. in the form of countless trillions of subatomic particles. The first stuff there ever was. Half these particles were made
And then
of
we can see there's like matter
the same
versus, so
kind of
after
stuff
light,
which makes us.
we have darkness versus light, and light expands and overcomes the darkness. We can see matter versus antimatter there in a face-off as well.
It seems as if
And you'll see a lot of explosions here with the matter, antimatter facing off. And matter overcame antimatter, right? Okay, so really cool view there. Again, all theoretical, all based on what we can only see and energy, physics, all that kind of stuff, right? So here's what I want you to understand, okay, about that. And we can see some really good visuals for it here, all right? Universe was created, and make sure I have all those guys on page 3. Okay, the universe was created through an explosion of infinite energy at a single point. So think of like a ball of light that's like the size of an orange, and then just expanding outward, out into the darkness and deep space. Okay, kind of like a balloon inflating. It wasn't like an explosion, it was like an aurora, beams of light expanding into space. The universe is approximately 14 billion years old. So very, very old, been around for a long, long time. I think our star, the sun, has only been around for maybe 3 or 4 billion years, if I'm not mistaken. I have to double check, can't remember. And then matter versus antimatter, matter was left over. So we had light overcoming darkness, and then we had matter overcoming antimatter. So pretty cool ideas there. Make sure to have all 3 of those on page 3. I'll leave that up for a minute. Okay, I'm gonna go. Let me see if I got one more question here. I think I do, but maybe we might call it a day. Let's see. Oh, I think that's all of our questions today. Yep, that's it for the questions. Okay. Let's see. Is that it? Yeah, that's all my questions for today. Okay, only had one question today. I thought I had another one. Okay. So that is it for today, guys. Don't forget, there's a new vocab called the Unit 8 vocab, like the word galaxy, supernova, all those words, 15 words. That's due next Friday. Okay. Let me go ahead and take attendance, and you guys will be all set.